This is the first video for the functions module. In this video we're looking at sections A and B. To begin, let's look at the objectives of the function model. Firstly, we're going to try to understand and use function notation. We're going to evaluate functions at given values. We're going to perform operations involving functions. We're going to determine the domain and range of functions. We're going to recall graphs of common functions, and we're going to plot graphs of functions. We're going to also sketch function graphs considering transformations and critical values, and we're going to determine the inverses of functions. Now, to begin with, let's look at some definitions and function notation. A relation is a set of points or ordered pairs, x, y. Note that xy is in brackets. Ordered pairs are always in brackets. The domain of a relation is a set of all possible x values. Okay? In contrast, the range of a relation is a set of all possible y values. So domain, you're looking at what x values you have. Range, you're looking at what y values you have. So let's look at an example here. List the domain and range of the following relations. So firstly, we have just a set of coordinates. Okay, so we've just got 4 points. So if we graphed it, we just have 4 points on the graph. So if we're looking at domain, we're looking at what x can be. Okay, so in this case, our x values, and we try and put them in order. Your lowest one's -3, then you've got -2, then you've got 1, then you've got 7. So they're the possible x values. Then we look at the range, which is a possible y values. Again, try and put them in order. -6, -4, 5, and 6. Okay, so it's just what x values you can have and then what y values you can have. Note the curly brackets, the parentheses that we put around them. Here we look at another relation, the relation xy such that x plus y equals 5. So if you think about that, the coordinates have to add to 5. So if my x coordinate was 1, my y coordinate would have to be 4. If my x coordinate was 3, my y coordinate would have to be 2. Now, if you think about it, I could have my x coordinate being 1.2 and my y coordinate would have to be 3.8. Wouldn't it? Because that adds to 5. So basically I can pick anything, can't I? So when I look at my domain, I actually say that it can be all real numbers, thinking back to the number system that you would have covered in Transition Maths 1. And your range, again, can be anything. So again, it's all real numbers. We could basically pick any two numbers. Once we know our x, we could pick any number y that makes it such that x plus y equals 5. So it can be anything. Now, we just looked at relations. Let's look at a function. A function's a relation, but it's a relation where no 2 points have the same x coordinate. Okay, so what that means is a function assigns to each input value x a unique output value y. So every x value has a different y value. Okay. So when you're thinking about that, you can't have, if you've got two x values that are the same and they have different y values assigned to them, then that's not a function. Let's look at some examples to try and explain it. Are the following functions? Okay, here we've just got 4 coordinates, so these 4 coordinates make up the functions. We look at the x values. Every x value there is different. Okay, so that means it is a function. Okay. Each x value has a unique output value. When we look at the next one, see how these x values are all the same? Okay, but the y values change. So in this case, there's 3 points that have exactly the same x coordinate, so therefore it's not a function. Okay, so what you're trying to look for when you're deciding whether something's a function in given coordinates are there x values that are the same, and if so, do they have different y values assigned to them? If so, can't be a function. Now, another way of working out if something's a function is with a vertical line test. Now, you can only do the vertical line test when you have a graph. Okay, to determine if a graph is representing a function, the vertical line test may be used. Okay, Basically all you do is you insert a vertical line and then you think about moving it along the axis. Okay, now if the vertical line only ever intersects the graph of the function in one place, then you have a function. Okay, so if the vertical line only intersects at one place, you have a function. So let's look at an example. Here I have 6 graphs and it says determine if the following are functions. So you think about, okay, well here's a vertical line. If I move this line at any point, anywhere along this x-axis, I would only ever cut once. Okay, doesn't matter which way I move the line, I will only ever cut once. So therefore it's a function. In the next one, I mean it's quite obvious, isn't it? If I put a vertical line here, I actually cut twice. So it's not a function. The parabola, again, I cut twice. So it's not a function. Next one's a hyperbola. You'll get to know all these graphs in this module. If I put a vertical line anywhere along here, it's only ever going to cut once. Okay? So therefore it's a function. Here, with an upright parabola, note the difference between these two parabolas here. This one's in the form of x equals y squared. This one's in the form of y equals x squared. But again, we'll look at that in more detail later. Only cuts once, so it's a function. Okay, this is a cubic. Again, I can put my, doesn't matter where I put my vertical line, I only cut once. So it's a function. Okay. So what can you do now? Well, you need to practice, and there's an exercise in the textbook, Function B1.